Welcome to another guide. In this video, I'm going to show you all the things that you need to know in order to succeed with your Prisma and PlanetScale project. Some of you have already tried out PlanetScale, and as you might know, PlanetScale has a bunch of nuanced differences to MySQL. And so today we're going to look at this from the perspective of an application. We're going to start by looking at all the workflows that you need to know in order to be productive with your PlanetScale database and Prisma. So let's dive right in. When starting out at Prisma and PlanetScale projects, there are three best practices that you should be aware of. The first one is referential integrity. And referential integrity is a bit of a broad term, so let's focus in on what it actually means. Referential integrity is a feature that is typically provided by a relational database like MySQL and Postgres. However, in the case of PlanetScale does not support foreign keys. That means that the referential integrity property that your database provides, where it ensures that you can only point to valid relations, and that your foreign keys are actually valid and they're pointing to rows in your database, that is no longer enforced in the context of PlanetScale. For that reason, we have to actually set the referential integrity in your Prisma schema to Prisma. And when you do that, what Prisma will do is it'll emulate the behavior of the database and try to ensure the referential integrity of your relations. So this is the first thing. The second thing is migration workflows with dbpush. PlanetScale is unique in that it allows for 100% online schema changes that are deployed automatically from what is known as database branches, a feature that PlanetScale introduced. This is quite different to the typical workflow with Prisma, where you use Prisma Migrate in order to generate SQL migrations for you based on changes in your Prisma schema. However, with PlanetScale, because the responsibility of actually applying the migration is on the PlanetScale side, there is no value to using Prisma Migrate. And so we're going to dive into how to use dbpush and what are the recommended workflows for schema migrations with PlanetScale using the Prisma dbpush command. The third and final best practice is to define indices on foreign keys. And this is related to the first point on referential integrity. So when referential integrity is set in the Prisma schema to Prisma, no foreign keys are actually being created in your database schema. And one of the side effects of that is that actually no index is also created for those relation scalars, for the field that represents the foreign key pointing to another table. And this leads to full table scans when relations for a query are fetched. And so in order to avoid these full table scans, which can slow down your queries and also increase your bills on PlanetScale, it is generally recommended to define these indices on these foreign key fields, and we're going to take a look at how to do that. So let's start by looking at a concrete application. Here I have the Prisma schema in a Next.js project that we want to connect to PlanetScale, and I've already gone ahead and defined the data models. So there are two models here, a post and a comment. This is going to be for a blog. And there is a one-to-many relation between posts and comments. This is also denoted by the post ID foreign key that we have defined here, and also the relation attribute on the post field. So the first thing that we're going to do is we're going to enable this referential integrity feature, and we're going to do that in the generator block. So here we have these preview features. We define that as an array, and I passed here referential integrity. The next thing is to actually set the referential integrity to Prisma so that we can create this database schema on PlanetScale. And for that, I'm going to also set this here to Prisma. When it's not set to Prisma, that means that we're delegating to this responsibility of referential integrity to the database. But of course, in the case of PlanetScale, we can't do that, hence referential integrity is set to Prisma. I'll run the formatter so it's nice. And now that we have our schema that we want to deploy to PlanetScale, we're going to create the database using the PlanetScale CLI, which I have installed here. So the command for that is pscale. And the command to create a database is pscale database create, and then the name of the database. And there we have it. So we have the PlanetScale database, and if we list the database, we can see that that was created. Now we're going to try to create a connection string for this database and set that in our environment variables so that we can run db push and create the database schema. So now that I've created the database, we can start thinking about how we're going to create the database schema. And this brings us to branches and how branching works with PlanetScale. So with PlanetScale, PlanetScale essentially supports two kinds of database branches: development and production. And development branches are essentially isolated copies of your database schema. And the main feature that they give you is that you can make direct schema changes onto them, and you can experiment with them. And this brings us to production branches. So production branches are highly available databases that are intended for production traffic. And production branches are protected from direct schema changes by default. And they also include automated daily backups. So typically, the production branch would be the main branch. And if I go back to the terminal and I list the branches, you can see that the main branch is there. However, it is not production. And the reason that it isn't production is because this is a new database. So typically when you create a new database, it just comes with a single main branch that isn't a production branch, which means that we can run db push directly against it in order to create the database schema. And then once we're ready, we can promote that to production. Once we've done that initially, this initial sort of promotion from development to production, that's where we get into the typical sort of branching workflow. And we're going to take a look at that in practice. But from a high level, the way it works is that once you have a main production branch, you would typically, if you wanted to make a schema change, for example, say you wanted to add a new column to one of your tables, you would create a new branch from your main branch, and this would be a development branch. You could name it any way you like, and in that branch you can actually make schema changes. So you can edit your Prisma schema, run db push, you can sort of connect to the database, you can do everything that you could do with a development database. And where PlanetScale is unique is how the schema changes work in action when you want to apply them to your main branch. So assuming that you created your dev branch, you made some schema changes, you added a bunch of columns, the next step would be to create a deploy request. And a deploy request would essentially resolve any schema conflicts and apply the changes with zero downtime. So this would be a non-blocking schema change to your main branch. So we're going to take a look at that later. But now that we have sort of a base understanding of how the branching works with PlanetScale, I think we can go ahead and create a connection string, connect to the main branch, and then run db push in order to create the database schema that is. And then we will promote it to production, and then we can take a look at the other aspects of this. Okay, so now we're going to create the connection string, and we're going to generate a new password. I'm going to copy that over into my environment variables file. And here I'm going to paste it. And now that I've pasted it, we can run the db push command. So npx prisma db push. And our database schema has been created, and it's now in sync. Now that our database schema has been successfully created, we can go ahead and run the seed script and try to populate the database with some data. And for that, we're going to use the db seed command. I already have a seed script defined. And it looks like we get an error because one of the values that is being provided in the seed script is too long. Let's take a quick look at the seed script and the Prisma schema. So here we have the Prisma schema. And on the right, I will open up the seed script. And the seed script just creates a bunch of posts and creates some comments for them. If we look at the actual posts that were being seeded, we can see that some of these are quite long, and these might actually go beyond what a VARCHAR field can store. So by default, when you're using MySQL, string fields are mapped onto VARCHAR fields. However, using the native types feature, we can actually tell it to use the DB text type, which isn't constrained the same way that a VARCHAR is. And so I'm going to just go ahead here and tell it to use text, both for the excerpt and the content. Just to be on the safe side, we can also add that onto the comment field. And now we can run db push once again, and then try to run the seed script again. Now, this is possible because our main branch has still not been promoted to become a production branch. Once it becomes a production branch, these kinds of changes will have to go through a deploy request. So let's try to run db push once again. Okay, now our database schema has been updated, and let's try to run seed once again. Great, so it looks like it succeeded. As a next step, we could also open up Prisma Studio and just explore the data in the database. So let's just take a look at post, and as we can see here, we have those 4 posts that we created, and each of these has a bunch of comments, so we can also look at the comments, and you can see that the post ID foreign key is still here, but if we look at the database schema, we will actually notice that there isn't a foreign key. So Prisma figures out by itself how to work with these relations, and there we have it. Okay. Now there's one more thing that I mentioned in the beginning, and that is defining indices on foreign keys. So we still have this foreign key, even though in PlanetScale it's not implemented as a foreign key. And because it's not implemented as a foreign key, it doesn't have an index, which means that for some queries, for example, if you're fetching a post and then getting all of the related comments for it, this will be a rather unoptimized query, because Prisma will try to fetch all of the comments that have a certain post ID. And because it doesn't have an index, it might have to do a full table lookup. And so in order to create an index on the foreign key, all we need to do here is just use this index property here on the model, and tell it to use post ID. Okay, great. Now we can go back into the terminal and run once again db push. Okay, that seemed to work. Now let's connect directly to the database. And here we have the 2 tables. And if we run the show create table comment, we should be able to see the index that we just created. And indeed, it has this index here on the post ID field. Okay, so I think we've covered all of the aspects that I mentioned as best practices in the beginning of the video. The first one was setting referential integrity in the Prisma schema and setting that to Prisma. The second thing is using Prisma db push instead of Prisma migrate for all migrations. And finally, adding indices on foreign keys. Okay, so these were sort of the main best practices. In the next step, I'm going to actually look more at how to create branches using PlanetScale and how to work with branches. So the first thing that we're going to do is we're going to go ahead and promote the main branch to be a production branch. That will mean that we can no longer make changes directly to that main branch and that we have to go through this deploy request and the branching workflow. And we're going to use that in order to add 2 more fields to both the comment model and the post model. So we're going to add a created at and an updated at column to both of these models. And we're going to do that using the branching workflow. And we're going to then create a deploy request. Okay, so now we're back in the PlanetScale console and we want to promote our main branch to production. And again, it tells us that we won't be able to make any more schema changes directly. I'm going to promote that branch, and there we have it. Okay, so from this point, we can't make direct changes to the main branch, which means that we probably want to create a development branch so that we can apply further schema changes. There are 2 ways to create a branch with PlanetScale. You can do that from the CLI tool, or you can create that using the UI. For simplicity, since we already have it open, we're going to create it from the UI, and we're going to call this branch dev. This could be more specific. We could also add created at to be a bit more specific about what we intend to do with this. And our base branch is going to be the main branch. So we're going to create that branch. And once it's been successfully created, we can then go back to our app, update the connection string, and then apply changes to our Prisma schema, and then run db push once again. And then at that point, assuming that we're happy with the changes and that the functionality works as we expect it to, we can then create a deploy request on PlanetScale. And this is also a good moment to remind you that when you create a new branch on PlanetScale, it's fully functional, so you can use that for local development. Another thing to point out is that you can actually connect to the database, or to a branch, I should say, to be a bit more specific. You can connect to it using a connection string, using a password that you create with PlanetScale, or alternatively, you can use the pscale connect command. So if we open up the help for this command, essentially what it allows us to do is it creates a proxy, a secure connection from our machine to PlanetScale, so that way we don't have to generate a password. So to do that, we pass in the name of the database and the name of the branch, which I forgot was add created at. Now, we might fail because the branch isn't ready. We can also use the pscale branch list in order to see. And as we can see, we have these 2 branches. We've already promoted the main branch to production, and the add created at is not a production branch, of course, nor is it ready, but let's see. And it's ready, so we should be able to use the connect command. And the great thing about this connect command is that you don't need to create a password, and if you're just developing locally, this can be quite useful. And now I'm going to go ahead and update the connection string in the environment variables so that we can connect to this database. And so I've already pasted it in, and I'm going to also put in the name of the database. And this is for development. Okay, so now that we've configured the environment variable, we should be able to run the seed command in order to populate this branch with some data. And so another quick note on branches. So when you create a branch, the schema is copied over from the base branch. So in this case, it was main. However, none of the data is copied over. And so now we want to populate that again with some development data to make sure it's all working correctly. And I will use the npx prisma db seed command. And great, so our database branch has been populated. Next thing I want to do is I want to go ahead and add the two columns to the two models. So let's open up the Prisma Schema once again. And here I am going to add a created at of time of type date time, and it defaults to now. And we also want to create an updated at also of type date time, and this will be updated at. And we also want to add that to the comment. We can add that after the ID. Okay, I ran the formatter. And so, okay, now I've introduced these changes to the Prisma schema, and we are connected to a development branch, meaning that we can actually apply the schema changes there. And the next step would be to go back into the terminal and run the Prisma db push command. Okay, so it's just telling us that we've added these two required fields, the updated at, but they don't have a default value. So in order to proceed, we have to reset the database. That's okay, we can reset it and then just seed it once again. Okay, so our database schema has been updated. Let's run db seed command, and then we'll open up Prisma Studio just to see what that looks like. And npx Prisma Studio. And now that we have Studio open, and there we have it. So we have the created at and the updated at both on the post and the comment models. So that's great. Now we can go back to PlanetScale and create a deploy request. So coming back to PlanetScale, here we have the page for the specific branch. And if we look at the schema here, we can see, okay, so this has been updated 10 minutes ago. If I go refresh schema, it should be able to detect that we've added this created at and updated at to both the tables. Okay, so this is exactly how we want our schema to look like, our production schema that is. And in order to do that, we're going to create a deploy request. So we're going to deploy this to main. We'll create the pull request. And this is the part where PlanetScale actually goes and checks whether this is even a schema change that is possible to deploy without causing any downtime. And we can also open up the schema changes, and there we have it. We get this really nice diff showing us what we're actually changing. So going back to the summary, it tells us, okay, the deploy request is deployable and there aren't any conflicts with the schema that are preventing deployment of these changes. So let's add these changes to the deploy queue. And the deployment succeeded. So these changes have been deployed. And now we can go ahead and actually just delete this branch because we're no longer going to be working with it. And if we go back to the overview, we have just the main branch. If we look at the main branch and we look at the schema, we see that we have the created at and the updated at. That means that we have successfully carried out a migration using the branching workflow by creating a deploy request. Let's take a quick look at the documentation diagram for the branching workflow. So we had the main branch, which we promoted to be a production branch, which meant we had, in order to carry out further changes and evolve our schema and add those created at and updated at, we had to create a new branch. We created this new add created at branch. We made some schema changes with Prisma db push. We created a deploy request. There weren't any conflicts. And so we were able to deploy those changes. Before we wrap up this video, I'd like to point out a bunch of things that are quite important to know when deploying to a platform like Vercel. So typically when you deploy to Vercel, you have two kinds of deployments. You have production deployments and preview deployments. And when you create a new branch in your repository that is connected to Vercel and you create a pull request, Vercel will automatically create a preview deployment. Now, what does this mean for our database? So as we know at this point, we cannot make schema changes directly to production. And as a general best practice, it's considered good to keep your staging, or in this case, your preview database, separate from your production. So the way that you can do this, and the way that I normally do this, is that I have a dev branch. The dev branch is the branch that I use for local development. And of course, because this is a non-production branch, I can make as many changes, make as many calls to db push as I need. And I also have the preview branch. And the preview branch is also being set as an environment variable in Vercel. So in Vercel, I have two database URLs. One is for production, and that points to the main branch on PlanetScale, and the preview database URL, which is shared for all preview deployments. And that can be a problem. And the problem specifically can be when you say you have two parallel pull requests, and both of them are making changes to your database schema. You can end up in a situation where one preview deployment doesn't work and the other does, and every time a commit comes in, then essentially there are races between those two pull requests because they're sharing the same database branch, that is. In an ideal world, you would have a database branch automatically created for you for each preview deployment. And if you've seen the serverless conference that Prisma organized, this is a big part of our vision, really, to enable teams to collaborate productively. However, as far as I'm aware, this is currently not possible. And so my general recommendation would be to use a separate branch whenever you want to make a schema change to the main branch. So that means if you have one pull request that is going to introduce some changes, you create a database branch on PlanetScale, and then here you can actually set an environment variable for only a specific branch. And so right now I only have two, but assuming that I was going to create a pull request and the branch for this would be add new fields, then I would be able to set that database URL for only that field. And what that would allow me to do is essentially make all of those changes in the pull request, in the Vercel build, or even manually. I would initiate the deploy request once I'm happy with that pull request. This could potentially also be automated with GitHub Actions. And once the changes have been made, a deploy request is made, and once that's merged into production, then you can actually merge the pull request. And you may think, oh, but why would you introduce a new field to your production database before you've actually deployed the code? And the general sort of approach there should be to always introduce non-breaking changes. You want to avoid as many breaking changes in your schema changes as a general rule of thumb. Of course, there are situations where you might want to remove a field, but in those cases, I would highly, highly recommend learning about the expand and contract pattern. And I think we have an article in the Prisma data guide which explains what this pattern is. But essentially, this pattern allows you to do these zero downtime, non-breaking changes. This is also the recommended workflow with PlanetScale. And on that note, I think it's also worth pointing out in the context of expand and contract that a good example for this is renaming a column. So renaming a column may seem like a trivial thing, but if you're trying to avoid downtime and you're trying to sort of work in a highly scalable environment, this is obviously not very friendly, doing renames. And so the general approach for doing something like a rename would be to use this expand and contract pattern, in which you would introduce essentially a new column. You would update your application code to write to that new column. You would copy over from the old column to the new column. And once you're happy with that, then, well, you can basically remove the old column. And at that point, all application traffic is already using the new column, and it's updated with all of the new data. So that's a little bit about the expand and contract pattern. I think this is also quite important, and it's also the reason why Prisma migrate should be avoided when using PlanetScale, and that is again because PlanetScale figures out the migration steps for you. You just make changes to the schema, and then essentially they do a diff and they figure out the steps for the migration, which means that any step that you would have created using custom SQL or SQL that you edited that was initially created by Prisma Migrate, that would be disregarded, and PlanetScale would figure out its own sort of migration path. So that's sort of to sum up the little topic of expand and contract, deployment, workflows, and so on. And before we wrap up this video, I'm going to do a quick recap of those 3 best practices that we started off with. To summarize, we started off with referential integrity. We looked at what it is. It's a property that the database gives you. We looked at how you can emulate this referential integrity with Prisma by setting the referential integrity configuration in your Prisma schema. And the main reason for this is because PlanetScale does not support foreign keys, and so we need to avoid those. In the second part, we looked at migration workflows. We looked at how DB push is the way to go. We saw how to use branches in PlanetScale when creating a new project, and then promoting the main branch to production. And then from that point, we had to create these database branches and create deploy requests. And we also looked at the need to create indices on foreign keys. So because foreign keys aren't really implemented as a database constraint, we also lose out on the index that we typically get with MySQL. And so we have to explicitly add the @@ index in our Prisma schema to make sure that when we do relation lookups and joins, that these do not perform full table scans and instead use the index. And in the end, we talked a little bit about what it means to be using PlanetScale as part of your development workflow as a team or as an individual developer. So I hope you found this video useful. If you have any more questions, feel free to drop them in the comments, or if you have a more involved example or question, feel free to join our Slack or open a discussion on GitHub discussions. And with that, I leave you and thank you for watching.